So here's, like I said, I gave you all those values. What we'll have to do is supply our own. And so let's work on a few problems. We're going to do two methods here to finding those percentages of values. First of all, we're going to use the empirical rule. The empirical rule for a normal distribution. Works for all normal distributions, no matter what the mean. We'll also just mention here, we'll also, on most of these problems, we'll be supplied with the mean, and we'll also be supplied with the standard deviation. But for any normal distribution, with any mean, with any standard deviation, this empirical rule holds true for any of them. Here's what it says. For any normal distribution, number one, about 68% of the values are within one standard deviation of the mean. About 68% of the values are within one standard deviation of the mean. What that means, if you look at the picture, is if I take my bell curve here and my mean, and what's the usual letter for standard deviation? S. Say my standard deviation is S. What this means is if I go out in both directions, one standard deviation means I can go backwards or forwards. If I go forwards, one standard deviation, that puts me at that value. I just add it to that. And if I go backwards, a standard deviation to that, what that tells me is 68% of the values are in here. 68% of the values are from this value, that's one standard deviation below and one standard deviation above. That percentage between them is 68%. Okay? But let me go ahead and do all of them. Now if I go two standard deviations, so if I go another one out and another one back, that's 95%. About 95% of the values within a standard normal distribution are within two standard deviations of the mean. So if I go, here's my x bar, one standard deviation, and then I go another standard deviation, I'm going two, forwards and backwards. One, and then another one. So I'm going from here all the way to there. That percentage is 95%. And there's one other percentage, and that is three standard deviations. That is about 99.7% of the values are within three standard deviations of the mean. So you're going pretty far out there. I mean, 99.7%, that's just about all of them. That doesn't leave too much, does it? 100% is the total. So anyway, yeah, within three, you've got 99.7. Okay? All right. So let's look at how we're going to utilize this. So these are the three percentages basically to remember for for a normal distribution, the empirical rule. It's called the empirical rule. Remember, 68 is within 1, 95% is within 2, and 99.7 is within 3. Okay? All right. So, how does that help us? Well, let's say we've got, for instance, the times to run a lap around a track are normal with mean 72 seconds and standard deviation 4 seconds. Let's consider a couple of examples. Number 1, what percentage of values are between 76 seconds and, not 76, 68 seconds and 76 seconds. I wanted 76 seconds, but I wanted 76 seconds to be the second value. Okay. What percentage of values are between 68 and 76 seconds? Well, if nothing else, you can draw the picture. Okay? If you don't get anything else right on this problem, you can draw this picture, right? It's a normal curve, so we draw a bell shape. What goes in the middle? 72, because it's the mean. 68 is on this side of the mean, so I put 68 over here, and then 76. However, what you want to do is look at it in terms of a standard deviation. How many standard deviations is it? So 68, how many standard deviations is 68 away from 72? Well, the standard deviation is 4. So wouldn't 68 be 1 standard deviation away from that mean? You with me? On these empirical rule problems, which is, I didn't state it, but that's obviously what we're using. I haven't told you about the other method. But using the empirical rule, that's what you want to ask on these values. How many standard deviations away from the mean are you? 68 is 1 standard deviation away, 1 standard deviation below, right? All right, what about 76? Well, 76 is how many away? No, from the mean now. It's just 1, yeah. Standard deviation is 4, so it's 1 standard deviation away, 1 standard deviation above. Okay, so I'm looking at this percentage, which it's 1 standard deviation below to 1 standard deviation above. What is that percentage from the empirical rule? Remember the 68, 95, 97. That's the 68, isn't it? Isn't that the 68%? 68% are within 1. That means from 1 below to 1 above. So isn't that 68%? That's what the empirical rule tells me. For any normal distribution, this means 68% of the values are from 1 below, are between from 1 below to 1 above standard deviations. So this answer is 68%. Okay? All right? Number 2. What percentage of values are between 72 and 80 seconds. Here's what usually generally will happen. Yeah, we're going to want to know these three values. This is the way I look at it. What percentage of values are between 72 and 80? Okay, well, let's draw our picture here and just shade what we're wanting. All right, what goes in the middle? 72, because it's the mean. The mean always goes in the middle. And then I want to go to 80. Now, let's mark it off. If I go one standard deviation, I'm at 76. If I go another one, I'm at 80. So it takes me 2 standard deviations, 1 standard deviation, 2 standard deviations to get to 80. So 80 is 2 standard deviations away, above the mean. So I want this percentage here. Now, which percentage up here has to do with 2 standard deviations away? It's the 95. However, the answer here is not 95. Why not? Because 95 goes from 2 standard deviations below to 2 standard deviations above. I'm only going to the above part. You see what I'm saying? The 95 would go 1, 2, from this 2 below, whatever that would be, to 2 above. I don't want that part. I only want, what do I do to figure that out then? I'm still going to use the 95. How do I get just this though? Well, it's symmetrical. The graph, the bell-shaped curve is symmetrical. So that means if I've got 95% from here to here, isn't that half of it, here to here? I only want from the mean to here, so I only want half of 95%. That will happen a lot on these problems. You'll have to take half of it. What's half of 95? 47.5.
Yeah, but I don't understand how that reading any difference than the one, our original one, or the one.
If I wanted the full 95, I would go, what would this be? This would be, one would be 68, this would be 64. If I wanted the full 95, I would go from 64 to 80. You see? I'm only going from 72 to 80. If this problem was from 64 to 80, that's 95%. However, I'm only going from the mean to 80. That's half of 95. That's right. Okay, so that in mind, what percentage of values are between 60 and 76 seconds? What percentage of values are between 60 and 76 seconds? Okay, well, let's draw a graph. Picture's worth a few words, right? Maybe a few points too. Okay. All right. 72 goes in the middle. Let's go to 60. Let's count it back. So I want to go how many back? One would put me at 68 back. Another one back would put me at 64. So I'm still at 60, so I need to go one more. I need to go a third one to get to 60. So how many standard deviations is 60 away? 60 is 3 standard deviations below. So I want that part. Now for the 76, well, that is on the other side. How many do I go there? Well, if I go one step, I'm there, aren't I? 76. So 76 is 1 standard deviation above. I want this percentage here, from here to here. Let me draw that mean down the middle, though. Okay. Well, we have a bit of a problem here. Because don't I have a mixture? I've got 3 standard deviations below, which percentage in the empirical rule is that going with? That's the third one, the 99.7. So I'm going to use the 99.7 for this. But this one's 1 standard deviation, so that's going to use a different percentage. That's going to use the which percentage? The 68. Okay? So I'm going to use the 68% here. However, I need to do a little work on them because I'm not going to add those because, for one thing, that would give me over 100%. Do you see here the 99.7% goes from 3 below to 3 above? I only want this much of it, so what do I have to do to the 99.7? Take half of it. Half of the 99.7% is that piece from 60 to 72, isn't it? Because of symmetry. The mean splits the 99.7 in half. You have half of the 99.7 over here, then you've got half of the 99.7 on the other side. And I only want the half of it over here, you see. So what's half of 99.7? 49.85. Now, supposed to be a percentage there. Same story on the other side. I'm 1 standard deviation above, so I'm using the 68%. That's what the empirical rule tells me. However, I only want 1 side of it, so I only want half of it again. A lot of times that's going this way with it. You're using half of those percentages, which is 34%. Okay, so I've got 49.85 here, I've got 34% here, so what's the final answer? Add them up, right? 49.85 plus 34 gives me 83.85%. So the percentage of values between 60 and 76 would be 83.85.